Hello folks, welcome back to Precalculus. Today we're in Chapter 6, Section 3, talking about the sum and difference identities, and we'll talk a little bit about cofunction identities as well. Okay, so what I'm going to do is I'm going to give you guys these identities, and then in class, if you would like to see proofs, I'm more than happy to give proofs, but it's just another toolbox of identities to add to what we did in Chapter 6, Section 1. Okay, so the first one, the cosine family sum and difference identity. So the cosine of an angle plus an angle, or the cosine of an angle minus an angle, is equal to the cosine of that first angle times the cosine of that second angle minus plus, and we'll talk about that in a second, sine of the first angle times sine of the second angle. So what that means is if we have plus or minus here and then you write minus plus here, that means if you have plus here, you should use minus. If you have minus here, you should use plus. Okay, so the sine of an angle plus an angle, or the sine of an angle minus an angle, is equal to the sine of the first angle times the cosine of the second angle plus or minus. So notice that if you have plus here, you're going to use plus. If you have minus, you're going to use minus. Cosine of the first angle, sine of the second angle. And then the last one, the tangent family identity, the tangent of an angle plus or minus a second angle is equal to tangent of the first angle plus or minus tangent of the second angle, all divided by 1 minus tangent of the first angle times tangent of the second angle. Okay, so those are going to be your sum and difference identities that we're going to use here shortly. Our cofunction identities, we've done these multiple times this year. Co meaning complementary function identities. Sine of an angle is the same as cosine of pi halves minus that angle. We saw that on the unit circle. And same, if this was degrees, we'd use 90 degrees instead. The secant of an angle is equal to the cosecant of its complement. And the tangent of an angle is equal to the cotangent of its complement. Okay, so there's your cofunction identities, and again, I can do those proofs in class if you'd like to see them. But let's take a look here. Okay, so right now we're trying to evaluate the cosine of 5 pi 12ths. And if you pull out your unit circle, you're not going to see a cosine of 5 pi 12ths, and we don't want to always rely on our calculator. So what we're going to do is we're going to try to make 5 pi 12ths using angles on the unit circle that we know, and then evaluate them using our sum and difference identity. So we're doing cosine, so we know we're going to be using this family identity. All right, so let's go through and look at it. I'm going to draw a little axis here. So now if you go through and you draw, like, there's pi 6, there's pi fourths, there's pi thirds. If you draw those, and we're trying to use these things to compose into 5 pi 12ths, let's make them all have the denominator of 12. So this would be 2 pi 12ths. Pi fourths would be 3 pi 12ths. And you probably notice we can stop right there. Because, and we don't have to go all the way around the circle, because 2 pi 12ths plus 3 pi 12ths is equal to 5 pi 12ths. So the cosine of 5 pi 12ths is the same as the cosine of pi 6 plus pi fourths. 2 pi 12ths plus 3 pi 12ths, pi 6 plus pi fourths. It's the same thing. Now we can use this cosine family identity that you guys see at the top. Cosine of an angle plus an angle is actually equal to cosine of the first angle times cosine of the second angle minus sine of the first angle, sine of the second angle. And now it's just about evaluating. So all I'm doing is looking at my unit circle. I'm not going to pull it into the screen every single time, but we know that the cosine of pi 6 is equal to radical 3 over 2. The cosine of pi fourths is equal to radical 2 over 2. The sine of pi 6 is 1/2. and the sine of pi force is radical 2 over 2, all pulled from the unit circle. And if we simplify those, notice that we're going to have 4 as a denominator here and 4 as a denominator here, so we're going to have a common denominator of 4. Radical 3 times radical 2 is radical 6, minus 1 times radical 2 is radical 2, and there's your answer. Okay, so now we're being asked to evaluate the cosine of 195. Clearly, we don't know the tangent of 195. Well, 195 is right here somewhere, but we don't know what that tangent value is. So we're looking for angles that we can add or subtract to 195. And here's what I'm going to choose, is I'm going to choose 60 plus 135. So instead of evaluating tangent of 195, I'm going to evaluate the tangent of 60 plus 135. And then use my tangent family identity. So tangent of 135 plus 60. And if we look up at our tangent family identity, that's equal to tangent of the first angle, so 135, plus tangent of the second angle, which is 60, over 1 minus tangent of the first angle times tangent of the second angle. Now we just got to look at our unit circle. Again, you guys should have this in front of you. The tangent of 135 is negative 1. I'm not going to pull this onto the screen each time. The tangent of 135 is negative 1. The tangent of 60 is radical 3. 1 minus, remember the tangent of 135 was negative 1, so that's going to make this into a plus. And the tangent of 60 is radical 3. And we're done. And there's our answer. Okay, let's keep going. So now we're trying to rewrite these two things as a single expression. If you look at it, they look very similar to our sum and difference identities. So if we're looking at this one, it looks like cosine of an angle times cosine of another angle minus sine of that first angle times sine of that second angle. To me, that looks like this family identity. And right here, I have a minus, which means right here, I should have a plus. So really, we're evaluating the cosine of theta over 3 plus theta over 6. If you want to combine those, you just need some common denominators. You guys know how to do that. This is just 2 theta over 6 plus 1 theta over 6, which is 3 theta over 6 or theta over 2. Really simple. Looking at this one, you probably guessed by now, oh, this is a tangent family identity. This identity right here. So I'm looking on top, I have a plus sign, and on the bottom I have a minus. On top I have a plus, and on the bottom I have a minus. Just now noticing that I forgot to put the plus sign on this identity. Here we go, we just added it. It's a minus plus on the bottom. So if we have plus on top, it's for you. We have plus on top, minus on the bottom, plus on top, minus on the bottom. That means we're going to have plus right here. Okay, so this is going to end up being the tangent of the first angle, x over 2, plus the second angle, x over 8. Add those things together. We can do a little common denominating here. So this would be 4x over 8 plus 1x over 8. So that's the tangent of 5x over 8. Okay, so there's two practice ones for you guys to try, or that we just did together. But now, here's one for you to try. So go ahead and pause your video and give this one a shot on your own. Go. Okay, let's keep moving here. Now we're being asked to evaluate the sine of angle x minus angle y. Okay, without even knowing really what x or y are. But they're giving us that the cosecant of x is this over this, and it's in quadrant 1. And the cosine of y is this over this, and it's in quadrant 2. So what I'm going to do is go ahead and I'm going to draw a picture of angle x. I'm going to draw a picture of angle y. So angle x is supposed to be in quadrant 1 with a cosecant. Let me turn into a triangle for us. Cosecant of 29 over 20, so meaning hypotenuse over opposite. If you do some quick Pythagorean theorem, we get that to be 21. Okay, so that's good to go. We got that whole triangle. We can evaluate all 6 trig functions of that triangle. Now let's do angle y. Well, angle y is supposed to be in quadrant 2, it said. So let's go ahead and draw it in quadrant 2. Turn it into a right triangle. It's got a cosine of negative 12. And this is supposed to be a 37, folks. I apologize. So let's make that a 3. So the adjacent is negative 12, and the hypotenuse is 37. If we do some quick Pythagorean theorem, we get this to be 35. Okay, so we've got our angles drawn right there, and we can use our sum and difference identity. So if you flip to the front, you can see, but the sine of an angle minus an angle is equal to the sine of the first angle times the cosine of the second angle minus the cosine of the first angle sine of the second angle. Okay, and that's just being pulled from right here. Sine of an angle minus an angle. Sine of first angle, cosine of second angle minus cosine first angle, sine of second angle. So let's just look at it. Now we got our whole picture here. So the sine of x, if we look at angle x, that's this one. Opposite over hypotenuse, 20 over 29. Cosine of y, negative 12 over 37. Cosine of x, 21 over 29. And the sine of y, looking at angle y here, 35 over 37. And if you multiply these, first of all, notice that you're going to have 29 times 37 on the bottom and 29 times 37 on the bottom here. That's going to be 1073. And on top here, all we have to do is 20 times negative 12. That would be negative 240. And then we got to do negative 21 times 35 is going to be negative 735. If you add those things together, you get negative 975. So there's our answer. So you see it's real simple once we have the picture drawn. Okay. Now let's take a look at the tangent of an angle minus an angle. Okay, real simple. We're just going to be using, we already drew our picture. We're just going to be using our identity from the front. So that's going to be the, right, a little higher. Leave us some space. Tangent of the first angle minus tangent of the second angle over 1 plus tangent of the first angle times tangent of the second angle. So now you guys had a second to write that. Tangent of x, 20 over 21. Tangent of y, 35 over negative 12. Fill in those values on the bottom as well. And there we go. Now what we need to do is some common denominating. Okay, obviously these negatives will make the plus. We're going to be adding a negative here on the bottom, but we need to do some common denominators. You need to find a common denominator between 21 and 12. the common denominator is going to end up being 84. And when you add those things together, you're going to get 325 on top. I'll let you guys do that on your own. You guys should know how to do common denominators by now. Now on the bottom, our common denominator will be whatever 21 times 12 is. So that's 252, ladies and gentlemen. So we want to change this number 1 to be 252 over 252. So that when you add it, or I should say subtract it, to this fraction, you already have common denominators. Okay, and you should end up with negative 16 ninths, which you can simplify to negative 975 over 448. Okay, now on your own, you're going to do these 3. They're exactly similar to these 2 that we just did. I'm going to give you a little hint. It tells you that alpha and beta are acute angles. That means that angle alpha is in quadrant 1. You can make a right triangle like that. That also means that angle beta is also in quadrant 1. Okay, and then you can use these to label your alpha triangle, and use this one to label your beta triangle, and then go through and do your identities. So go ahead and pause your video and make sure that you have these 3 completed before you submit your notes. Okay, hopefully you got those 3 questions done, and now we're just going to play with the cofunction identities really quick. These are real simple. Remember, we talked about cofunction being complementary function identities. The sine of 18 is equal to the cosine of its complement. So the cosine of 90 minus 18, which is the cosine of 72 degrees. You can stop there. I'm not going to make you get your calculator out. But if you did and you want to check sine of 18, cosine of 72, you're going to get the same answer. Okay, same thing here. The cotangent of some angle, this pi 6 plus y, that's just some angle, is equal to the tangent of its complement. So the tangent of pi halves, minus this angle, okay, which is just pi over 6 plus y. Okay, we can go ahead and distribute that negative sign if you want. That's tangent of 3 pi 6. Notice I was clever and turned my pi halves into 3 pi 6. Minus pi 6 minus y. 3 pi 6 minus pi 6 is 2 pi 6, which is just tangent of pi thirds minus y. So there's your answer for that one. A big lesson, I know, and I'm sure you guys have questions on these 3 above, but make sure that they are done coming into class before you submit your notes, and then I can answer questions as you guys need. I look forward to helping you.